Hello, everyone. My name is Zach Schubert, and this is my presentation on the Charge Tape Lab for Physics 2212. So, in the introduction, I'm going to be talking about the main ideas as well as the topics we use to make calculations and to justify our observations. Then I'll be giving a brief overview about the results of the experiment, and then as well as some additional notes and assumptions we made. Main ideas. So, in this lab, we were asked to create static electricity on a piece of tape to create a charge and see how it reacted with different objects. Then we are also expected to find the amount of excess charge on one piece of tape. So in this experiment, we use Coulomb's law for force, as well as Newton's third law for every action there's an equal and opposite reaction. So for the results of the experiment, we found that the tape is negatively charged. The two charged tapes repelled each other when in a close enough proximity, and then it attracted to neutral matter and then repelled the negatively charged pin. We found that the tape has a charge of 6.07 times 10 to the negative ninth coulombs. And then we also found that the tape has 3.79 times 10 to the 10th power excess electrons. Notes and assumptions. So we define the system as the charge U tape and as well as whatever object that is interacting with. And then the surroundings would be the earth or any external forces. We also ignored things like air resistance and any other external forces because they had no significant effect on the results of the experiment. And then we also assumed that the charge is evenly distributed throughout the tape and that each charge was the same for each U-tape. Now for the main part of the experiment, we had to levitate a piece of tape since they were the same charge, they repelled each other. And this is our initial conditions, finding the length of 20 centimeters, the mass of 0.2 grams. The separation distance is this to see how high it levitated. And then we found the force of gravity using force of gravity equals mg. And then we also use that, since it is not moving, you can set the forces equal to 0. So that means that the electric force, since it's the only force acting on it defined by the system, it will be equal and opposite of the force of gravity. Calculations. So the first thing we did was found the magnitude of the gravitational force using F equals mg, and we found that to be 0.002 newtons. And then we know that the magnitude of the electrical force and the magnitude of the gravitational force are equal to one another. So we then use that to plug into the equation to find electrical force, to find the charge of a piece of tape. So when we did that and solved for Q, we found that Q equals 6.07 times 10 to the negative ninth coulombs. Next, to find the number of excess electrons, we divided the charge by the charge of an electron. The coulombs units cancels out, and you get 3.79 times 10 to the 10th power electrons. Next, to find the number of atoms on tape, we found the area of the tape, and then we also found the number of atoms per square meter and multiplied the two to get 3.8 times 10 to the 17th atoms. Then finally, we found the ratio by dividing the two to get 9.97 times 10 to the negative 8 electrons per one atom. Next, we created a 3D model using GlowScript. We represented the two pieces of tape as point charges as seen here, and in this, the orange arrow represents the gravitational force and the green arrow represents the electrical force. We also had to output the charge on one piece of the tape. Sources of error are the same as the assumptions we made. We had to ignore all external forces and assume that the charge is evenly distributed. And then we also considered the charge as a point charge when it's more like a line charge or it has multiple charges, just to make things simpler. So the final thoughts for this experiment, all right, our what if question. So let's say that electrons were positively charged and protons were negatively charged. Would this change the experiment? No, because that would mean that protons are negative and electrons are positive. That means if you have one of each, they would still attract each other, or if you had two of the same, they would still repel each other. So therefore, it would not change the experiment at all. Okay. Why is it important to touch the tape as little as possible? This is important because the more you touch the tape, the more likely the charges are to jump from the tape to your hand, leaving the tape chargeless, meaning that it will no longer react the way it did before. And then what happens when the tape comes into contact with your hands or other objects? Like I said before, it will lose its charge and will not have the same effect. It will become essentially neutral. That's it for this experiment. Thanks.